BIM is called Building Information Modeling, and it's a system that architects and engineers use, a system of utilizing software to get us closer to reality, actually closer than any hand drawing or sketching or painting has ever been able to do in the past.
Hi, I'm Ruben Olage with Dimensions. Throughout our system, construction sites such as this one are the byproduct of building information modeling. That means nothing got here without its use. And in our universities, the use of BIM in classrooms is giving students a definite edge.
One of the things that they always tried to teach us was how to think in different views and sort of think in almost a virtual world. And all of that was really, obviously, in your mind, in your head. With something like BIM, now you can create, mold, do shapes that are attached to information and detail and cost in an instant on a computer screen, where it would have taken hours and sometimes days to draw up concepts and so forth.
Experts in the field of architecture agree. Virtual design was originally conceived to eliminate redrawing, conflicts in construction, and recalculation of costs, to name a few. With BIM, an old gap between design and construction was compressed considerably by integration.
What BIM is doing is that as a technology that has been evolving over many years, it's not something that has been just recent, it has taken many manifestations. BIM is offering a platform through which that integration is happening, aided and enabled by technology.
At A&M's College of Architecture, the integrated practice is called AEC Approach, Architecture, Engineering and Construction, where BIM sits at the head of the table.
The BIM model becomes a central point for all of your information about the building. That's why it's a building information modeler. It's not merely a computer-aided drafting system or even a three-dimensional rendering system. It's a three-dimensional rendering system plus a very powerful database and query tools that allow you to query the data in the database, query the model, query the geometric model, and manage all of that in one central location.
In this example, Dr. Clayton shows how a basic BIM sequence allows the viewer to understand any given construction design.
So I could say hide everything but the roof, show it all again. I can hide the roof and get a view showing the inside of the building. So the BIM tool gives me a lot of powerful ways to manipulate visualizations, to produce reports that I want.
Outside classrooms, aggressive competition has taken a peculiar form. Architectural designs include, well, even the steam from a coffee cup. Technology presses on, professionals are relying on multiple models based on BIM for a single construction. 3D has been surpassed.
But now we're talking 4D. When you add 4D, you're adding the opportunity for the model to be looked over time. So the model looks like this in time 1, time 2, time 3. So you're embedding time as the model evolves, but it requires to be designed in that way that you can actually make 4D a reality, and there has been lots of research and there are commercial packages that offer 4D.
Even with 4D coming into the picture, A&M's construction expert Julian Kang considers BIM to be simpler than it seems.
You don't have to be construction professionals to be able to understand what will be going on in the construction phase, so that even doctors and nurses can see how the construction process is going to affect their daily processes, their daily life in their facility.
For architecture students, being able to understand probably translates into better grades. Trick is not forgetting the core of the trade.
Accepting, respecting, and protecting the essence of what architecture is, what construction is. You know, engineers do that on their own, but for us, it's protecting that essence of what we are.
For Dimensions, I'm Ruben Olave.